بسم الله الرحمن الرحيم. الحمد لله رب العالمين، والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. This is section 5.3 and it's about the fundamental theorem of calculus. The fundamental theorem of calculus has two parts. Both parts are discussing the relation between the two important calculus problems, the integral and the derivative. And we will see that the differentiation and integration are inverse processes. The fundamental theorem of calculus part 1 says that if f is a continuous function, and this is an important condition, on a closed interval a, b, then the function g of x defined by this definition, integral from a to x f of t dt, this function is continuous and differentiable. So we can find the derivative of this function, and the derivative would be f of x. So it says that the derivative of the definite integral with respect to its upper limit x, so this is the variable we are dealing with, is the integrand evaluated at the upper limit. So it is f of x. Or we can write it like this. It can be written as, instead of g prime of x, we can write it the derivative d by dx, the derivative of this integral with respect to x would be f of x when f is continuous. So if we first integrate the function and then differentiate the result, we will get back to the original function. To illustrate the meaning of this function, maybe this function doesn't look easy, this one. So I will give one example. Let us talk about the function f of t equals 2t plus 1. And let us find the area, find the integral of f of t dt from 1 to 3, for example. Okay, so I will find the integral by the area method, okay, by graphing the function and finding the area below this function from 1 to 3. So at 1, 2 times 1 plus 1 is 3, and at 3, 2 times 3 plus 1 is 7. So this is 3, and this is 7. And this would be the line. This is the line 2t plus 1. Okay, this is the line 2t plus 1. So here, this is f of t, which is 2t plus 1. Now, to find the area below this line, this curve or line, and from 1 to 3, which this means that we need to find this area. This is a trapezoid, and the area of the trapezoid is the sum of the length of the bases. So this is the first base from 1 to 3. So the length of this base is 3. So 3 plus. And the length of this base is 7. So it's 3 plus 7 over 2 times the height. And this is the height from 1 to 3, which is 2. So the answer is 10. So the area of this region is 10 square units. Now let us define the function g of x equals from 1 to x f of t dt, okay, where f of t is 2t plus 1, f of t dt. So this function is the same as this function, okay? where a is 1. And I'll show you that the derivative of this function would be equal to f of x. So what is the definition actually of this function? Well, the integral starts from 1 to x. Let us say, for example, x is here. Okay. So x is a number between 1 and 3. X is a number between 1 and 3. And we are talking about the integral of f of t from 1 to x. So this area, it represents this area. And if x changes, it will give you another area. So this is actually a function now. It's not a constant like this one. The definite integral here, the answer was just 10. So this is a constant. But if we call this x, this would be a function of x that gives the area below f of t from 1 to x. Now let us find this area. Okay. So again, this is a trapezoid, and the length of this base is 3, and the length of the other base, this base, is f of x, because this is x. So this point is x f of x. So this length is f of x, which is 2x plus 1 over 2 times this length, the height, the distance from 1 to x, which is x minus 1. So I have 2x plus 4 over 2 times x minus 1, or if you take 2 as a common factor and cancel with the 2 in the denominator, I have x plus 2 times x minus 1. And this is x squared plus 2x minus x plus x minus 2. So this is the function defined by this integral. It is equal to x squared plus x minus 2. And as you see, it's a function of x. If x changes, it will give you the area below f of t from 1 to x. So for example, if you take x3, if x is 3, then g of 3 would be the area below this line from 1 to 3. If you replace x by 3, 9 plus 3, 12 minus 2, 10. And we already evaluated this area and found that it's actually 10. So now the first part, part 1 of the fundamental theorem of calculus says, if you find the derivative of this function, you will get f of x. So let us find the derivative of g of x, or g prime of x. Well, the derivative, as you remember from calculus 1, is 2x plus 1. And what is this? This is f of x, because f of t is 2t plus 1. So f of x is 2x plus 1. So we have seen here an example about this fact, that the derivative of the integral of f of t dt from 1 to x is f of x. And this is the first part of, or this is part 1 of the fundamental theorem of calculus. An example, find the derivative of this function. Well, d by dx of from 0 to x square root of 1 plus t to square dt now, using now the first part, or of the fundamental theorem of calculus. The derivative of this function, of this integral, would give you this function with respect to x, f of x. So the answer is 1 plus x squared. That's it. The derivative cancels the integral, and you have square root of 1 plus x squared, not t squared. Another example here to find this derivative. Notice that the problem here, we don't have x, we have x to the power 4. So whenever we need to find the derivative of the integral, but this time it's not 2x, not from a to x, it's to f of x, a function of x, okay? a function of x, and here you have f of t dt. Well, this function doesn't have to be the same as this, so just let me call it g of x or h of x. Okay, so what is the derivative in this case? If we replace x by f of x, if we replace x by g of x, not f of x, because uh, the one inside we already call it f of t. So what would be the derivative? It would be this function f at g of x. This is similar to this one. Here we have f at x, okay, but this time, since this is g of x, not g of x, not x, we will multiply by the derivative of g, which is g prime of x. So this is using the chain rule. So here, what would be the derivative of this integral? It would be this function secant at x to the power 4, and then we multiply by the derivative of x to the power 4, which is 4x cubed. So the answer would be 4x cubed secant x to the power 4. That's the derivative of this integral. The second part, part 2 of the fundamental theorem of calculus, deals with the derivative, the integral of the derivative. The integral of the derivative. So here, also again, remember an important condition, f should be continuous on the closed interval AB. So the integral of the derivative of f is capital F of b minus capital F of a, where capital F is an antiderivative of small f, which means that if capital F prime equals to small f. So this means to find the integral of a function, you need to think of an antiderivative of this function. Antiderivative means a function in which you find the derivative, and you obtain small f. Okay, so for example, uh, if we need to find this definite integral, okay, now this part, this theorem gives us another way to find the definite integral, a new way. What is this way? Think of a function that has ex as its derivative. So we know that d by dx of ex is ex. So we know that the derivative of ex is ex. So ex is an antiderivative of ex. So according to this theorem, we will have the answer would be small f here. Small f is ex, and capital F is also ex. Okay, so we have e to the power 3 minus e to the power 1. That would be the answer. If capital F of x, this is capital F, e to the power 3 minus f of a. Sorry, here, capital F of b minus capital F of a. If we replace b by small x, by a variable x, to make this function, to make this as a function, and we have, instead of f of x, of course, f is the derivative, so we write it f prime t dt. Then the answer would be that we can write this theorem in another way, uh, which means the integral of the derivative would be the function itself. Okay, the integral of the derivative of a function would be a function itself plus or minus a constant. Okay, so differentiating a function and then integrating the result will arrive back to the original function except for a constant. So when we find the derivative of the integral, we get the same function. But when we find the integral of the derivative, we get the same function but with a constant. This is the fundamental theorem of calculus using the two parts. Here we have some notation. We can write f of b minus f of a like this, f of x from a to b. So this symbol means f of b minus f of a. Or even we can write it like this, okay? ab or like this, AB. All of these three symbols mean f of b minus f of a. So for example, here, to find this definite integral, now if small f of x is 1 over x, I need a function capital F of x which has 1 over x as a derivative. So what is the function in which you derive, you get 1 over x? If you remember, it's ln x. The derivative of ln x is 1 over x. So capital F is an antiderivative of small f. So the answer would be ln x from 3 to 6. This is the notation we just wrote. So the answer would be ln, you replace x by 6, minus you replace x by 3. This is f of b minus f of a. If you remember, ln y minus ln x is ln y over x. So we can write it ln of 2. So the answer of this integral is ln of 2. That's the end of this section. I hope you enjoyed the lesson. Have a nice